Hello everyone, in today's video we will be tackling a Leetcode problem called Unique Paths 2. This is a classic problem that can be solved using dynamic programming, and you may encounter the problem or its variations in interviews every now and then. So you should fully understand the technique to solve this problem and be able to pass all test cases quickly and correctly. First, let's understand the problem statements. Given a grid with obstacles, we need to find the number of unique paths from the top left cell to the bottom right cell. The grid consists of cells, and some cells may contain obstacles that cannot be crossed, like this one. Our task is to determine the number of valid paths while avoiding these obstacles. The problem gives two examples. Let's check the first one. The first one returns the value of 2, which means we have two paths to reach the bottom right cell. The first path would be to go right, then go down. The second path would be to go down, then go right. Notice that you cannot use any path that contains this obstacle. Then let's check the second example. The return value for this example is 1 because there is only one path to reach the bottom part cell, which is to go down first, then go right. You cannot go right, then go down because there is an obstacle in it. To solve this problem, we will use a dynamic programming approach. To see the reason behind it, let's first consider how we can calculate the number of unique paths to the second row in the third column here. It should be equal to the number of unique paths to its upper cell here, because we have to pass the upper cell to reach the lower one. We cannot reach this cell from its left because there is an obstacle in it. But what if we didn't have this obstacle? Then our answer will be the addition of two parts. The first part is the same as before. It's the number of unique paths to reach its upper cell. The second part will be the number of unique paths to reach its left cell here. There are no other possibilities because we can only reach the target via the two cells. There are other cases too, but I won't illustrate them here. I will talk about them afterwards in the code walkthrough parts. The point is we can calculate the number of unique paths to reach each cell by using the value of its previous cells, which is the essence of dynamic programming. That's also the reason why we use this method. In the end, we will get the number of unique paths to reach each cell, including the last cell. The number of the last cell will be our answer. We can return it safely. Let's write the code and explain each case along the way. We first define m as the number of rows in the grid. And we define n as the number of columns of the grid. Then we create a two-dimensional array dp. The column count and the row count of dp is the same as obstacle grid. dpij represents the number of unique paths to reach cell ij from the top left cell. So as you can see, dp m minus 1 n minus 1 will be the answer. Then we iterate through the dp array and fill its value one by one. After the iteration, we just return dp m minus 1 n minus 1. So let's traverse the two-dimensional array. Now let's see how we can set the value of the cell in DP array. First, if there is an obstacle at ij, like the second row in the second column in this example, then there will be no path to reach that position. So in this case, dpij will be 0. So if obstacle grid ij is equal to 1, then dpij will be 0. Otherwise, we check if I is equal to 0 and j is equal to 0 too. In this case, we are located at the top left corner, which means dpij is 1, because there is only exactly one way to reach that position, which is our initial state. Otherwise, let's check what if I is equal to 0 and j is greater than 0. It means that we are in the first row, like here or here. The robot can only move horizontally from the left cell, like from here to here. So in this case, dpij is equal to dpij minus 1, which means the value of the cell is equal to the value of its left one. Otherwise, let's check the case where j is equal to 0 and I is greater than 0. It means we are in the first column, like here or here. The robot can only move vertically from the upper cell, like from here to here. So in this case, dpij is equal to dpij minus 1 j. Otherwise, I would be greater than 0 and j would be greater than 0. In this case, the value of dp will be the addition of two parts. The first part will be the value of its upper cell, and the second part will be the value of its left cell, because we can only reach the position ij from these two cells. And after that, we just return dpm minus 1 and minus 1, and that is the number of unique paths to reach position m minus 1 and minus 1, which is the bottom right cell. And that's it. You can see that this algorithm is pretty efficient. I hope you find this video helpful and gain a good understanding of the problem and its solution. Feel free to implement the code yourself and explore further. If you have any questions, please let me know in the comments below. If you like this video, please give it a thumbs up and subscribe to it. It will be really helpful for me to continue this channel. Thanks for watching and happy coding. Bye!